a SOC analyst looks at two things: IP addresses and port numbers. In the last video, they're all over the screen. If those two things mean nothing to you yet, that is fine. By the end of this video, they will, because almost everything in cybersecurity sits on top of one idea: how data moves from one machine to another. I'm Unsalted, I work in cybersecurity. Let's get into it.
The big picture.
Let's start with what actually happens when you open a website. You type an address. Your computer sends a request across the network to another computer somewhere else in the world that holds the website. That computer sends the website back. That is it. That back and forth, a request and a response, is the whole foundation. The machine asking is called the client. That is you. The machine answering is called the server. Every single thing you do online is some version of this: a client asking, a server answering. So the real question is, how does your request find the right machine out of the billions that exist? And that is where the first key idea comes in.
IP address, the analogy.
Think about sending a letter in the post. For a letter to reach someone, it needs an address, a specific house on a specific street in a specific city. Without that address, the letter goes nowhere. The postal system uses it to route your letter across the country to exactly one front door. A network works the same way. Every device connected to a network has its own address, so data knows where to go. That address is called an IP address. It is the home address of a machine on a network. When your request travels to a website, it is addressed to that website's IP, and it carries your IP as a return address, so the answer can find its way back.
IP address, the real thing.
Now, let's drop the letter and look at the real one. An IP address looks like this: four numbers separated by dots. Each number goes from 0 to 255. That is the most common format, and it is called IPv4. Here is something useful that confuses a lot of beginners. There are two kinds. A public IP is the address the outside world sees. Your whole home network shares one public IP given by your internet provider. A private IP is the address used inside your own network. Your laptop, your phone, your TV each gets its own private IP, and these usually starts with numbers like 192.168. This matters in security because when a SOC analyst sees an alert, one of the first questions is simple: is the IP inside the network or outside it, internal or external? That one detail changes everything about how worried you should be.
Ports.
So the IP address gets your data to the right machine. But there is a second problem. One machine does many things at once. The same server might run a website, handle email, and manage file transfers all at the same time. So when your data arrives at the machine, how does it know which service it is for? Back to the address idea. Imagine a large building with one street address, but many numbered doors. The street address gets you to the building. The door number gets you to the right office inside. On a machine, those numbered doors are called ports. The IP address gets your data to that machine. The port number gets it to the right service on that machine. And many of these ports are standardized, so the whole world agrees on them. Web traffic usually travels on port 80 or port 443 for secure web. Remote access into a machine often uses port 22. You do not need to memorize these yet, but you should know the idea. An IP address plus a port number points to one exact service on one exact machine anywhere in the world.
Why this matters for security.
Here is why a defender cares about all of this. Every port on a machine is a possible way in. A door that is open is a door an attacker can try. So one of the most basic things in security is knowing exactly which ports are open and making sure the ones that do not need to be open are closed. When an alert fires, this is what the analyst reads first: which IP started the connection, which IP it was talking to, and which port it used. A connection going out to a strange address on an unusual port is exactly the kind of thing that makes a SOC analyst look closer.
Recap.
So let's bring it together. Every device on a network has an IP address, its home address. Every machine has many ports, the numbered doors to its different services. Every computer, the client, sends a request to a server's IP address on a specific port. The server sends a response back to IP. A client asks, a server answers, and IP addresses and ports make sure it reaches exactly the right place. This is the foundation the entire internet runs on, and it is the foundation every cybersecurity alert is built from. Once this clicks, a huge amount of security starts to make sense because you can finally read what an alert is actually telling you. In the next video, we go one level deeper into protocols, the actual languages machine used to talk, and the specific ones a SOC analyst watches every single day. If this helped, subscribe, See you in the next one.